Today we will be talking about limits by factoring. My name is Janine Ko and I make educational related content videos like this. If you're interested in seeing more, please subscribe to the channel and hit that notification bell. For the first example, we have limit when x approaches 0, and right off the bat, you see that when you plug in 0 into your x value, you result to an indeterminate form. So for us to get rid of that indeterminate form, we need to expand 2x plus 3 squared. And first of all, what's an indeterminate form? So an indeterminate form just means that you are unable to evaluate the limit of individual functions. So in that case, you're looking at your numerator and your denominator. So for us to expand 2x plus 3 squared, and for those of you who find it difficult to remember formulas, including myself, I like to remember the Pascal's triangle in terms of the coefficients. So we have this formula a plus b, and this is squared. So you would have a squared plus 2ab plus b squared. So as you can see, the coefficient of a is 1, and that's 1 in the Pascal's triangle, and you have a coefficient of 2 for ab, and that's 2 in the Pascal's triangle. And for b squared, you have a coefficient of 1, and that's right here in the Pascal's triangle. Okay, great. So we figure out the way to go in terms of expanding 2x plus 3 squared. So now we expand that term. So we have a, which is 2x. We have b, which is 3. So we know that if you square a, in this case, this would be 2x squared. This would result to 4x squared. And if you square b, this is just going to be 9. So we can rewrite our term into 4x squared, and we have 2ab, which is 2 times 2x, and this is times 3, so you would get 12x. So this is plus 12x, and this is plus 9, and don't forget, we still have the minus 9, therefore we still have that minus 9 over there. And this is all over x times x plus 1. So as you can see, 9 minus 9 results to 0, and it cancels out, and we're left with 4x squared plus 12x over x times x plus 1. So when you factor out your x, you would have x times 4x plus 12, and this is all over x times x plus 1. Now we can actually cancel out x in both our numerator and our denominator. And also, the reason why I didn't factor out 4 in this case, even though there is a greatest common factor of 4 in our numerator, it's because it's not really necessary to be factoring out 4 because it doesn't allow you to cancel out more terms. So just keep it there. And then from there, we can evaluate the limit when x approaches 0. So we have 4x plus 12, and this is all over x plus 1. By direct substitution, we would have 4 times 0 plus 12, and this is all over 0 plus 1. We see that this is 0, so we're left with 12 over 1, and our limit is 12 for this example. Now moving on to number 2, we have limit when x approaches 4, and we have x squared minus 16 over x minus 4. So right off the bat, we see that when we plug in 4 into our x, we're going to get an indeterminate form, which is 0 over 0, because you have 4 squared minus 16, so 4 squared is 16 minus 16, and you have 4 minus 4, and this results to 0 over 0, so this is problematic. Therefore, we actually need to expand x squared minus 16. If you recall, we have a formula, difference of squares, which is a squared minus b squared. So this is a plus b times a minus b. So this is the formula for difference of squares. Now what we can do for x squared minus 16 is expand this in terms of x plus 4, right? Because we're supposed to find just b coming from b squared. So when you take the square root of 16, that's just 4, right? And you have x minus 4, because it's a plus b times a minus b. And finally, in your denominator, you would have x minus 4. So your x minus 4 cancels out in both your numerator and your denominator. And now we're ready to evaluate the limit when x approaches 4, and our modified expression is x plus 4. So this is after when you got rid of x minus 4. Now, we just have to plug in 4. So 4 plus 4 is just going to give us 8. Therefore, the limit is 8 for number 2. Now let's move on to number 3. We have limit when x approaches 0, and similarly, we have to apply the formula that we were looking at using Pascal's triangle. So this is a plus b, and this is squared, so this is a squared plus 2ab plus b squared. And I just like writing the formulas because it's just easier to visualize on paper, and you just have to apply it, right? So you have x squared plus 3, and this is squared, right? So ultimately, we need to figure out what a is and what b is. So our a is going to be x squared, our b is going to be 3. So, and also 2ab, right? So 2 is going to be multiplied to x squared, and you need to multiply this to b, which is 3. So that's just going to give us 6x squared for the middle term. Now we can expand our expression. So this is x squared, and you square that, so this is x to the power of 4. For 3, this is just simply going to be 9, right? So this is x to the power of 4, so I'm expanding my numerator, and this is going to be plus 6x squared, and this is plus 9 minus 9. So just keep in mind that you have your plus 9 minus 9, which is going to give you 0, right? And ultimately, you can actually factor out your x squared. So this is all over x squared, and this is equal to x squared over here. So you would have x squared plus, and this is going to be 6. And this is all over x squared. So as you can see, you can cancel out x squared in both your numerator and your denominator. And finally, you're left with x squared plus 6, and we're ready to take the limit when x approaches 0. So this is just going to be 0 squared plus 6. So we're applying direct substitution, so 0 plus 6 is simply going to be 6. So our limit when x approaches 0 is 6.